The second force acting on gravity dam is self-weight. Okay, self-weight is the major resisting force of the dam. This self-weight resists all the external forces that are coming to the dam. Okay, when we draw the cross-section of the dam, if the cross-section is like this, it is upstream face is truly vertical and the downstream face is partially vertical and partially inclined. Self-weight, in order to calculate the self-weight, we can divide this cross-section into number of rectangles and triangles. That is, this dam can be divided into one rectangle and triangle, and we can simply calculate the weight of this rectangular section, and that weight will be acting at the centroid of this rectangle. That is, W1 will be acting through the centroid of the rectangular section, and W2 is the weight of this triangular portion, and that will be acting at the centroid of this triangular area. So we can find out the total weight, and that weight will be acting at the centroid of this entire cross section. Okay, if the cross section is like this, upstream face is partially vertical and partially inclined, downstream face is also partially vertical and partially inclined. In this case, in order to calculate the self-weight, we will divide the dam into one rectangle and two triangles. The weight of each portions, W1 will be taken as the weight of the rectangular portion. W1 will be acting at the centroid of this rectangle. This is the centroid of the rectangle. Weight will be acting through the centroid, and if this is the centroid of third triangle, weight will be acting, W3 will be acting at the centroid of this triangle, and if this is the centroid of the triangle, W2 will be acting at the centroid of this triangle, and we can finally calculate the total weight W, which will be acting at the centroid of the cross section. Okay,